All right, this time I have a blank board to start out this conversation. What we're going to be talking about is how do we know when a function is increasing and how do we know if a function is decreasing? Well, since we're dealing a lot with rates, we're dealing with slopes. When our slope is positive, our function is increasing. So if we know our f prime of x is greater than 0, that means it's positive. That means f of x is increasing because it has a positive slope. If our slope or our derivative is less than 0, well then we know our original function f of x is decreasing. Plain and simple. Positive and negative slopes, that's what we're looking at. Where is my slope positive? Where is my slope negative? That tells me increase and decrease. So let's look at an example. So if I told you f of x equals 2x cubed minus 9x squared plus 12x minus 5. Well, I want to know where my derivative is positive and negative. Well, if you think about it, on a graph, to be able to go from positive values to negative values, what has to happen? I have to pass through 0. So what I want to know is where does my derivative equal 0? I want to find those critical points, right? So I'm going to take my derivative. So I'm going to get 6x squared minus 18x plus 12, and I'm going to set it equal to 0. So I'm going to factor out that x, or that 6, off of my x squared. All right. And I'm going to keep factoring, so that's going to give me x minus 2 and x minus 1. So my derivative equals 0 at x equals 2 and x equals 1. So that's where we're going to see the changing from increasing and decreasing. So what I'm going to do, this is called the first derivative test. I'm using literally the first derivative, and it's going to help me test to see if something is positive or negative. So I'm just going to create this number line, and I'm going to put my critical points on here. So here's 1, and here's 2. So again, these are where the function has a derivative of 0. So we can put this here just to, organize our thoughts. I want to know where my derivative is increasing or decreasing. So I'm going to pick a point on each interval here. So let's say here, I'm going to plug in 0. And I'm going to plug it in to this part of my derivative. 0 minus 2, that's a negative. 0 minus 1, that's negative. Negative times a negative is positive times a positive 6. This is a positive derivative. Okay? So right here, I'm seeing f prime of x is greater than 0. That tells me from negative infinity to 1, I'm going to be increasing. From negative infinity to 1, f of x is increasing. So my original function. Okay? Well then, what's happening between 1 and 2? So I'll plug in 3 halves, or 1.5. Okay? 3 halves minus 2, that's a negative. 3 halves minus 1, that's positive. Positive times a negative is negative, times a positive 6 is still negative. So this is negative. So at this point, I can tell that my derivative is less than 0, which means from 1 to 2, my f of x is decreasing. Okay? All we're looking at is that positive and negative value of my derivative. Okay, and then one more, my open interval here, I'm going to plug in 3. 3 minus 2 is positive. 3 minus 1 is positive. Positive, positive, positive. That's going to stay positive. So here, I can see that my first derivative is greater than 0. It's positive. So at that point, we're going from 2 to infinity. F of x is increasing. At 1 and 2, the slope is 0, so it's not increasing or decreasing, but we can tell the intervals of increase and decrease. I love this stuff. It's so cool. So if you got questions, you're confused, let's figure it out.